So friends, I think we have a few steps behind us moving into virtualization. We have a few steps before us before we get to the end of we know how to virtualize. And we know what to virtualize, we know how it will basically perform and what it will do. What I will talk about now is how we then go from that learning and understanding into moving into zero-touch reality after that. Because that zero-touch reality is pretty important. And before I get going, I'm just going to talk a little bit about why I think that's important. And on Monday, for those of you who were at the Etsy CSM workshop, we went through a little bit more details of how we as an industry is moving towards that. And the elephant in the room, which unfortunately I haven't heard too many people actually speak about and be willing to open up on, is that doing things manually, everyone claims, yeah, you know, we can't continue doing that in 5G. So when we deploy 5G, we have to automate. Sure, that's okay. But the brutal reality is that look at the web scale companies. They are automating what they do today. They have those areas and aspects automated. If you start looking at what happens when you get a greenfield operator, which deploy and start from the scratch to automate. In this case, let's look at what's happening in India over the last period of time. So what happened in India? Well, we had a greenfield that started from basically an outset of everything I deploy, everything I operate needs to be automated. What's happening in India? They completely changed the market, completely changed the game in one of the biggest markets in the world, by subscriber base, obviously. So the automation topic and the zero-touch reality is, at the end of the day, a live or die topic. The thing that protects some operators is that it's difficult to get access to spectrum in certain markets, so it's difficult for people to go in and do greenfield. But if you, in your market where you are, have a risk that there will be spectrum availability and people can go in greenfield, there's a huge risk, if you are not ready to automate, that they will simply undercut you across the board on any cost basis. So in the abstract, I outlined that we have a few things to look at. And these things are really outside of whether you have a specific environment in mind, if it's an OSM or an ONAP or whatever. Sure, it's not necessarily the best topic of the day to discuss necessarily microservices in an ONAP environment. I know people get a little bit stitchy about that, but I anyway choose to call it microservices. We can discuss later on how that would look and feel in an ONAP environment. If you really would like to go down that line, I'm more than happy to do that. But if you talk about it from a functionality perspective, and there are still a number of things to look at. And I think the key here is to say, how do we get to this so that it becomes useful, so you can drive these use cases? And just to illustrate this evolution, and I won't dwell on this slide, but it basically where we're moving from something very monolithic today in very many segments, both from a network management perspective and from a solution perspective inside the network. Those are monoliths. They are hard, expensive to move there. We all know that it moves into an automated environment, orchestrated, etc. The key is, it doesn't matter if it is this specific platform, which would be an OSM or an ONAP, or if it's something you develop yourself. This will happen anyway. So if you now do this and you try to achieve zero touch, what could be the steps? And I'm just talking about a couple of use cases here, and then from that, I will look at, see, what do these things drive in commonality? These use cases are things where it's either possible to deploy them today, as they are realities, or as in the last, the last one here on the list is an example of a project where we and Viavi, together with a number of other parties, did an EU project for the last 3 years to basically do research on how do we get zero-touch management of a 5G fronthaul use case, and how do we, from that, drive both new SON capabilities and optimized scheduling, etc., and resourcing across a completely disaggregated RAN environment in a 5G case. So the rest of them, the first 4 ones here, are basically use cases which I believe are very much a reality today in what you can deploy. So the first one, I think, is something that intuitively a lot of people have been doing, and are wanting to move towards, which is much more customer self-care, much more ensuring that both consumers and businesses can do self-service management, etc. The key with that is that it's easy to give people a portal, click a button, and then things are supposed to happen. But what happens when things go wrong? Can you continue with the self-care management when things go wrong? And the answer is basically yes, but you have to be a little bit smart about it. And reason is I go through this is that I think and hope that you all resonate with these use cases, and that these are steps towards the zero-touch reality. Let's just say these are not necessarily enough in order to go to a, call it, lights-out, blackout data centers, just throw in a service model and things operate with, say, intent-based management, etc. But these are steps towards that. And when I talk about this, I talk about the reality today and things I think you can do today. And overall, the next question is, if you want to move to this environment, how do you make sure that you, from a DevOps perspective, have a continuous delivery, continuous integration, continuous deployment model when you, for example, deliver new services? So, for example, if we see that there is a significant uptake in basically customers need to run VPNs. We know all of the security concerns in the industry today. More and more people start using VPNs. Those put new stress on your core networks. How can you, in a DevOps process, make sure that whatever configurations you had before is now evolving and able to deal with this? That's another use case where you get certain capability set that needs to work through this. Being able to validate that whatever configuration that is now working is going to evolve to those new needs, which may actually happen, obviously, very, very quickly. And to give examples of that, I'm not going to go into details of that now. That's a talk I did a couple of years ago. But if you think about from an OTT perspective, how many of you remember, for example, these viral videos that went around? Gangnam Style, as an example. Between day 1 and day 7, Gangnam Style pushed huge amount of traffic onto every network. Every teenager, every adult, me, my wife, everyone basically looked at this across the world. It came from nothing, and then it ended. If you don't have the right caching mechanism, if you don't have the right models to deal with that, your network will be overloaded. Similar, you probably remember games like Angry Birds or other things like that, which goes from 0 to very, very highly used and populated across the world in just a matter of days. Similarly, VPN, we see this uptake start based upon the security concerns happening. So DevOps model needing to deal with that from an automated manner, being able to deal with it, manage the results, and then drive the changes necessary. Then we have, call it bread and butter business. We all know MEF LSO. We know how MEF LSO help us drive interoperability carrier interconnects. We know how this allows us to deliver business services today. I would imagine most of the operators in the room already have this operating one way or the other. That's great. And it gives us building blocks to work from. Those building blocks are fundamentally standardized APIs, standardized capabilities to deliver these endpoint connectivities, and then the ability to validate that they work, ability to make sure that they continue to operate, and once they continue to operate, you can obviously then optimize them, tune them, etc. But more importantly, you can then, in an automated manner, deal with both outages, reconfigurations, etc. Another topic, which we will go into a little bit in more detail, is around the closed-loop assurance use case. I will step through that in detail, so I'll leave that for now. And I already mentioned about the case of the fully dynamic sort of front-haul 5G use case. This is the one which is more forward-looking. And these use cases all drive a set of requirements. What you will see in a minute is that we believe, and we have the certainty, that this will boil down to a set of core capabilities. Those core capabilities is, in our opinion, different from what a lot of the industry think about today, where a lot of the industry think about and standardize and push, for example, if it take from an ONAP perspective, that everything should be possible to do from, for example, a VES feed from any of the VNFs, or using, for example, DMAP to be able to do policy management, etc. There are other things we believe needs to be done. So with that said, let's jump into this closed loop scenario. And this is a activity we did together with Cord and the Cord environment. So what we did is that we basically had 2 network slices. These 2 network slices we basically monitored. We monitored them with a quality of service real-time feed. So this means that we basically had each of those network slices generating obviously traffic across the network. In this scenario, we then, on a per second level, got a throughput level on each of the network slices. The problem domain here was that across this network, there was a vSwitch, which unfortunately had an issue. That vSwitch got some problem with certain type of traffic. The vendor of the vSwitch was working to resolve it, but until it was resolved, we needed a closed loop fix to the problem once it occurred. So the key is, how can you detect that an incident occur? How can you secondly identify which vSwitch is the impacted one? And thirdly, how can you resolve the problem? Fourthly, how can you verify that the problem was resolved? And fifth, how can you make sure if there was any users that had a quality of experience degradation? I assume everyone is really familiar with the difference between quality of service and quality of experience. Those are 2 very important factors to separate. So in this case, we basically had an ability to trigger when the throughput went down on the network slice. So this is an end-to-end network slice. In the delivery chain, there's multiple switches between point A and point B. And in this case, this starts an active troubleshooting to identify where in this delivery topology is there a problem. Practically speaking, this was a matter of taking a TWAMP test and walking through the topology to identify the node that stopped forwarding traffic. This node, we could then inform the policy manager about, hey, this node has stopped forwarding traffic, take the right decision. The policy in this case was to respin a new vSwitch, configure that one, and move the traffic towards that vSwitch instead. So simple fix, but the question was, could you do that quick enough so that the platform basically was able to detect the problem, recover from the problem without the quality of experience impact? And the answer was that practically it's possible if you have the right and swift quality of service capability. In this case, we were getting data once every second. Secondly, the next point is, are you able to quickly take a decision on what to do? And is it quick to respin, in this case, the vSwitch at the right point and insert the traffic? And then the next point was, once we have this incident taken care of, we know the time period of between A and B, we know the impacted users, we have a quality of experience probe calculating the quality of experience impact of any users during the time, and we feed that up to a CM system. And that can deal with, is there anyone at this point which is at risk of churn and had a negative impact at this event, and therefore we should have an increased churn risk of this individual, and we should potentially proactively deal with that. And obviously, from a DevOps perspective, the key from our perspective is that, can you give the engineers the right tools so that when things happen, they can build automated incident detection, automated troubleshooting to identify the root cause, and then the resolution. These things they do manually normally. They've learned how to do these things manually over the years in normal networks. Now it's a matter of giving them tools so they can drive that DevOps capability. Similarly, as I said before, on the VPN scalability model, this is a case of where you have a core network, you start to see, for example, that there's a significant uptake of new VPN usage, then being able to very quickly take from, once again, from a DevOps perspective, take and perform that in the running environment, being able to validate how it works. And now even more importantly, if you realize that, hey, this is now starting to underperform. A lot of the industry now speak about how do we drive predictive analytics. So predictive analytics really is based upon, in many cases, that you have a ability to train a model on when are things going to go bad. And once you know that things go bad, you can start predicting how long beforehand do I know this, and can I respin or can I add capacity, etc. to it, or can I reroute traffic or other things? If you now think about it from a perspective of, now you have a tool which can walk through the various error scenarios. Those various error scenarios you can do very quickly. In a DevOps environment, you spin that up in your sandbox. In the sandbox, you can create any error scenarios you want, overload, etc. That's now your training data. So you take the telemetry you're getting out of your VNF, take the telemetry you get out of the rest of the system, you have it connected to what you do with when you create the error scenario, voila, now you have training data for your machine learning process. You don't have to hope that other training systems or machine learning models or AI ops, etc., which doesn't need training data, will function. Once again, I speak about reality of things we can do today, not things we maybe do at some point in the future. So, step by step, think about this, the right set of capability, the right Lego blocks that enable a zero-touch reality today. And some of the things we believe are needed, and by the way, this is not a shopping list from my company. This is a thing we believe are needed in order, from a test and assurance perspective, if you want to have a set of Lego blocks that enable you to drive not only the use cases I spoke about now, but a set of other ones. And the key here is that, and it's basically from an atomic level on the left-hand side to a very composed level on the left-hand side here. The key here to understand atomic versus composed is that atomic is basically, if you take the simplest case, I think we've all been there. We sit at home, internet connectivity is really slow, and I go to speedtest.net and I hit do a test, and it shows I can do 20 megabits. Question now is 20 megabits good or bad? Is it good or bad? It all depends. Am I supposed to have a 1 gig connection? 20 meg is pretty bad. But that comparison and knowledge is something that is part of a composed answer. So that's basically where you start to see on, for example, service activation or monitoring, service monitoring as a use case, etc., or as a service. This is really where you start to add intelligence around it. And once again, if you were here on Monday when we spoke about the Etsy CSM environment, we have the various domains in that where we talk about the intelligence domain, the analytics domain, and the assurance domain. This is really where some of these microservices belong in various areas. And based upon that, once again, moving from today over to a future framework, regardless of which one it is, you're likely to see these type of functionalities in various blocks. So, is any one of these, from my perspective, more important than the other one? And there's a few ones which are really, really important. And the first one is a ability to do domain orchestration. So test domain orchestration or assurance domain orchestration. And why do I say that that's important? That's the one that I believe is going to help the rest of the industry to move forward. That's where you do the separation of concern and you do build intelligence and analytics capability relevant for that domain. If you look at what AT&T did in eComp, they had this capability internally. If you go and look at eComp, they have that domain controller capability. If you look at what's in our own app, it is excluded. That's not because it's not useful. It's because it contains a ton of interesting IPR, which wasn't interesting to submit to the open source foundation. So when we start looking at this, there is a couple of things that stand out. If you as well start looking at other ones, like, for example, troubleshooting as a service or root cause as a service, etc., this is where a lot of the policy vendors work hard on this. So I would imagine that there's going to be a set of policy solutions that will have a number of these type of APIs and interfaces. So that's really where we get into a combination of things that interconnect and build up the whole end-to-end framework. This whole end-to-end framework with other third-party microservices, and you recognize these from many other places, like the service orchestrator, the network orchestrator, the infrastructure orchestrator, etc. These things add up to it. And here is where you see, from my perspective, the VNF metrics as a service, which in an own app perspective is the VS feed, that is one of these data services and data activities that are important. But equally important is things coming from the NFVI layer, etc. We already mentioned the domain controller. I believe that if you're looking for this one, there's a good RFC talking about one standardized way of implementing it. I would recommend everyone to look at that one. We were part of doing that. AT&T were part of building the standard, and a few others. And we are seeing similar adoption in other places. So in summary, I think you can deliver closed loop assurance today. I believe you can do strives towards a complete zero-touch operations today. And my advice is partner with the right partner. I believe that's Viavi. I think we have the right capabilities to be your partner. And with that, I just want to leave it with that. Viavi is a company, global company, about 3,500 people, about $1 billion of revenue this year in the end of the day, and we are globally represented. Thanks a lot.